Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to explore some various ways we can use to detect data drift and then model drift. So what is data drift and what is model drift? So simply put, data drift is in case you are trying to do any or provide any machine learning solution. There are three main components. We have your data, we have your model, and we have your code, right? So any changes that you find within your data aspect of your produced solution, of your ML solution, can be termed as a data drift. So if there is a change in the data, we normally call it as data drift, right? So changes in the input data, changes in the values of the features used to define or predict a target label, or changes in the properties of the independent variables can all be termed as data drift, right? So one little coder, you can check one little coder, he has a very nice explanation about it. So simply put, this is it. So in case you have a simple machine learning model, right, and we have the target label, right, which is what is going to be predicted, and then we have the independent feature, right, or independent variable called S. Any changes you find here in the X, right, this is the features, can be termed as data drift, right? So it can be a feature drift, which is referring to the changes in the independent features, or covariance shift, in which there is changes between the units of the features, right? Individual features here. That is covariance shift. So that is data drift. But if there is changes inside what the model is trying to predict, with these ones being the same, that is termed as concept drift, right? So concept drift in a way can be a form of label drift. So label drift is if there is a change in a label, but concept drift is changes in what we define or how the model defines what it means to be a target. For example, like if you build a model that is predicting what is termed as fraudulent, right? A fraud detecting or predicting model. If there is changes in how you define what we mean by fraud, that is concept drift. But if you change fraud to criminal, right, that is a target drift, right, or a label drift. So concept drift is the definition of what we mean by the target has changed, right? So everything is the same, the association is the same, but what we mean by the fraud has changed. So it's going to affect the entire model. So that is something very basic. So let's move on to how to detect data drift and then model drift using some various packages. So there are a lot of packages you can use. So some of these things include model monitoring, and you can use MLflow, you can use weight and bias, you can use scikit multiflow using the Adwin algorithm, you can use River in case you are doing online machine learning, you can use DeepChecks, which is what you'll be trying to use in this tutorial. You can use evidently.ai, you can use Pachyderm and Prometheus to monitor some other stuff. You can also create your own custom functions to monitor changes in your data and in your model. Okay, so let's see how to use DeepChecks to do data drift. So I'll go back again to my workspace, and then we start writing some code. So in case you want to install DeepChecks, I can just go back and install the pip install DeepChecks. So I'll go back to my terminal. You can see that I've already written it here. So it's going to be pip install DeepChecks. That is how to install it on your system. Very simple. Okay, so let's go back and see. So I'm going to load my packages, so pandas, and then my machine learning packages, and I'm also going to load my pipeline to build our model. Perfect. So let's load the dataset and let's explore this dataset. So it's going to be df.head, and if I go back and I check it out, you see that we have our dataset with all of these things, right? So we have our label as y, and then our features, right? So let's split them into our features and our labels using this particular function, and then we can see all our features. As you can see, perfect. So the y is out. So all of these things are our features. So any change we have here can be termed as data drift, right? Perfect. Now let's split our data set into training tests, and then we build our model. So in trying to work with DeepChecks, there are various caveats that you need these things. So you need your data set, which is your train and your test data, and you need your model, right? So these are the main requirements. And DeepChecks have some various components, three main components. It has the suits to do some data integrity checks, data drift checks. We have the checks for label drift, feature drift, and we have the data set to build your own data set to fit into DeepChecks. Okay, so let's see how to work with it. So I'm going to build that model. So let's build the model, and then work on it. So I'm going to use pipeline, so pipe lr. I'm going to call it as my pipeline. I'm going to pass in my steps, right? So steps, which this simple pipeline we are building is going to take in some steps, right? So it's going to take in the data to data stage and data to model stage. So for the data to data stage, we have my scikit-learn standard scaler to scale the data set. Perfect. And then we also do the same thing for the model. So this is going to be the model, and then you use logistic regression model. Right. Perfect. Now we have our simple model. Perfect. So let's train our data, or train our model. Train to fit. Right. So it's going to be my pipe allow.fit. Then I can pass in my strain and then my y train. So it's going to train it, and it's going to give us our result. Perfect. So let's check it out. So let's check for the accuracy of this particular model. I spelled accuracy more than accuracy, right? So it's going to be my pipe. The simplest way is just allow.call. Now I pass in my s test and my y test. Right? This is the simplest method. If I check it out, it's 91%, right? Very good, very high. Perfect. So how do you check for model drift? Using DeepChecks. So let's check DeepChecks. So this is using DeepChecks for offline, yeah, right, or offline ML, right, something like that. So this ML data drift detection. So let's see how to do that. So it's very simple. So we're going to load in the package, and then we will explore the various components. As I said earlier on, it's having 3 main components. So it's going to be import DeepChecks. If I check it out, let's check for the various methods of this particular package. So there are DeepChecks, and then you can see the various things that this particular package has to offer us. So let's check it out. If I check it out, you see we have these basic stuff. So we have the suite, as I was saying. So that's not the most important. We have the dataset to build custom dataset to fit for DeepChecks. We have the suite, right, with different suite, and then we have the last one was the checks, right? You have the checks, as you can see, right? You have the checks. So let's see how to build it. So we have the checks, the suite, and then dataset. So I'll come back again, and then I'm going to load them, and I'm going to build a simple one. So this is going to be the first full suite. So the full suite is going to give us the option of doing data drift detection. We can also use the same thing for model performance, right? Detection, right? You can check for the model performance. You can also use it for dataset integrity. You can also check for label ambiguity. A lot of things, right? There are a lot of things you can do with this ambiguity. You can also use it to do some other checks, right? Like the model performance, the model confidence, all of these things, right? You can even use to detect bias in case there is something inside. So let's see how to use a full suite for that. So let's go back again and check it out. So it's going to be, first of all, we need to make sure that we are importing the package. So from DeepChecks.suite, from suite, right? Then I'm going to import full suite. So that is what we are trying to import. So from DeepChecks.suite, we are importing full suite to help us do our stuff. Right, perfect. And now with the full suite, you can build our first stuff. So we have imported it. Remember that the requirement is that we need a data set, right? So we need the data set and then the model. So we need to build the data set, and then we need the model. So I'll come back here and I'll pass in my data set. So let's create the dataset class, right? So it's going to be the circleless objects. So to create it, let's call our ds train, right? And the dataset class is coming from DeepChecks. So DeepChecks.dataset, which is coming from here, the one we imported from above. Remember that we had dataset here, right? So that's what we are trying to import to work with. So in case you have any question or contribution, you can let us know. Then this one takes in some arguments. So it's going to take in some argument. So the argument is going to take in the data frame, right? The data set. So in this case, I'm going to be using strain. And then this is going to take in my label. So the label here is going to be my y train, right? And you can also pass in this is it. So that is it, right? You're not passing the model. So I'll do the same thing for the other one, so the test. And then this one for the test. That is how to. So we have created our data frame. Some columns have been fed as categorical, right? So some of them are categorical. So you can also specify those categorical features here by going this. So cut, right? You can also do that, but categorical features to specify those categorical features, right? But let's leave it like that. Because it's smart, it's able to detect those categorical features, right? You can also actually use them as you wish, right? So automatically detecting that there are some categorical features there. So let's move on straight away. Perfect. Now we have created our data set over there. So the next thing is to create our suite. So let's create our suite. So create the suite for checks, right? So it's going to be my full suite. So let's call it F suite. It's going to be my full suite. That is all. You don't need any other stuff, right? So perfect. And then from there I can now pass in my data. So let's call that my result, or you can, my result is going to be my F suite, then .run. Now passing my DS train. So DS train, and then my DS. So this, we can make it simple, be explicit to train dataset. Let's go to this, in my test dataset is equal to DS test. That is all, right? And then you can also pass in your model. So the model that you're using is the pipe LR model. So that is it. So it's going to take some time for it to run. That's going to generate some very nice report about it. So it's doing a FullSuite check. It's going to give you a report on the data drift, on the confidence score, on the model performance, on the dataset integrity, on the label. So there are a lot of checks it's going to do behind the scene, right? Which is very cool. Model error analysis is also going to be doing model error analysis to see if there's errors within your model. So let's give it some time, and then let's come back again. Right? Perfect. So it's running. So it's label ambiguity. So it's going to run several checks, right? It's going to generate a very nice plot, right? A very nice report for us. Perfect. So that's finished. Now I can just back again, and then I can just go with results. If I run results, now you can see the very nice plot, right, of everything. You can actually run it without putting inside a variable. Any of them is going to work, right? You can go without the variable, so you see the plot straight away. Perfect. That's come. You can see that it's giving us, that's generated all of these wonderful reports just with a simple line of code, right? Just with this 3 set of code, these codes, right? We have been able to generate a very nice report on the entire data set, and it's going to give you explanations of it, right? What it is doing. So we have pass, we have fail, and we have warning, right? Very nice. So these are all the things it did. So model information, category mismatch, train test, index train test, leakage, and the rest. So you can just check them out here. So we have the condition. This checks with condition, checks without condition, checks without output. So it's going to tell you if there is duplicate, right? So this is as you can see, we have these 3 things, right? Warning, right? So warning, fail, and then pass. So both of them, there are warnings there because some of them may be having duplicate rows. We have pass for the train test sample mismatch, whole data set drift for data drift. So it passed, right? The drift value is not greater. And then you can also do the same thing for the train test label drift, and for label drift, data size comparison. So all of these things, it passed for the data drift. And the model performance, right? Inference time, the time it takes for you to make a prediction, all of them it passed, right? So it gives you a lot of things out of the box, right? Very cool and very nice. But apart from that, you can also do the same thing for the ones with condition, right? For the trust score comparison. So trust score comparison is used to check for the model confidence, right? Without taking into consideration how the model implementation. So it's another way you can use to check for how performant a model is, right? How trustworthy your model is. Very nice. And then you can also move on from there, and you can see the trust score, right? So this is the train data set. You have the test data set, and for the test data set is the blue one, and then for the train, right? So it went away around this particular point, right? Very cool. And then one of the things about this is that like some of these plots, it gives you information about it so that you can actually read what it means. And you can also see the worst trust scores. So any number that is more than 2, right, more than some of the trust score, these are the worst trust scores. You can't, although it is predicting, the model predicted 0, 0, 0, but you can't trust these particular predictions, right? Although it is correct prediction, but you can't trust it because the trust score is low. It is performant, right, but it is not trustworthy. But if you look at these ones, these are the top trust scores. So you see they are very high. So you see that it's giving them the same prediction and then the actual value. So that means that you can actually trust these particular results. Very cool. That is one aspect of it. You can also come back again and do for the data duplicates. You can also check for, these are the rows with duplicate values. You can also check for model performance. This is the performance of the model, right, which is very cool. So using the F1 score, precision, and then the recall. So let me reduce it so I can see it well. And it's very cool, right? So there are a lot of cool things you can also do with this particular package. So it's going to give you the precision, right, the F1 score and the precision, and then these things you can actually save it because I think it's using plotted behind the scene. And then you can also see the ROC curve, right? Out of the box, you can see the ROC curve. You can also see the same thing for the training and the testing. You can also see the sample model comparison. And you can also check for the features that were not used, like feature importance. So which of the features are the most important? So just one little code is giving you all of this information, right? So these are the features that are important and the feature variance, right? Very nice. And it's going to give us the last shown significant features. So these are the most important features, and then these ones are not that important. Very cool. You can also check the inference time, and then you can also check for the drift, right? So this is where you just check for the drift using the earth mover distance. That is the minimum amount of effort you need to take, right, to pick a date, right? So it's simply put like this. So it is very minimal here. It seems that there is very little drift here. So that means that the model is performant. Like there is no data drift, right? If I'll check another, I'll show you in another video. I'll try a different model, and then you see the difference, right? You can see that the test and the train, they are all almost following the same pattern. So that means that there is not that much of a drift. There's no drift. It's very, very minimal. If the drift is more than this, then that means that there is a shift. But if there is no drift, it's very minimal, that means that the model, there's no data drift, right? Very cool. Using the edge mover distance. It's not using the Adwin, it's using the edge mover distance. Not do the same thing for the top features, right? So for the P days, for the feature number 4, feature number 3, feature number 2, like for each and every one of the features to detect if there is feature drift, right? That is data drift for each of the top features. And then you can also go back again and do the same thing for the train test label drift, right? Which is very nice. Just able to give us the prediction of the label drift so that there's no drift because the drift score here is empty. So there are a lot of things you can do, so too much of the talking. So you can check it out to see what you can do with it. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below. And then one more thing, all of these things we have done, you can actually do them individually. So let's quickly do a simple one for the feature drift, right? So I'm going to do one for feature drift. So this is going to be for feature drift. Let's make feature drift or data drift. Simple one. Instead of using the checks, you can also use it. So instead of using the suits, you can use the checks. So let's check it out. So it's very simple. So this time we are not using the suit, we are using the checks, right? So it's going to be very simple. It's going to be from DeepChecks .checks, right? And then I can import. There are a lot of things I can import. So you have the train test split. We have train test feature drift, label drift, trust score comparison. So let's go for the feature drift. Perfect. And now we can just create our simple check. So let's go as my FD check, or let's call it as just checks like that, right? And I'm just going to initialize it. So train feature drift. You don't pass in anything, and then the next thing you're going to do is you're going to go with checks.run. Then you pass in your strain. So train dataset going to be my DS. This time you're not going to be passing in this, you pass in your model, but for the label drift you don't pass in your model, right? Perfect. So this one you pass in. If it's a feature drift, you pass in your model, right? I'll just pass in here. Let's make it like this, like we do it. Result. Let's run it again, and then after that you can just check the result. So check is checks, I call it. Let's make it check so that it doesn't confuse with this. And let's run it again, and then you just get the result back. So that's the basic understanding. So that is the same thing. You can also do the same thing for label drift, right? So that's how to detect drift within your dataset using DeepChecks. Okay, so let's check it out. If I check the result, okay, so now it's going to calculate drift between trained dataset and test dataset per feature, right? Very nice, because this feature drift is going to give you the result, right? So for the top 5. So as you can see, there is no drift within the dataset. There is no drift, and you can see that there's no drift, like based on the earth mover distance, it's the same, following the same pattern. And then the same thing for the next top feature, right? And then the next one. So that is how to do feature drift, right, using DeepChecks. So in the next session we also check on label drift, right, in case you want. So thank you for watching, and see you in the next session. So to recap, to work with DeepChecks is very simple. All you have to do is just import your particular check you want to do, initialize it, you work on the data set, then you just click on run, right? That is how to work with it. I can also do the same thing for the rain, like this, for the label drift with this option. So for the label drift, it's going to be this. So it's going to be label drift. So the same thing here, the same thing we did. So let's call it as L check, and then let's call it as L result. So run it. This time you are not passing in the model, right? We don't pass in the model for this thing, so it's going to just check for the label drift. It's going to give us that there is no drift, right, between them. Very cool, right? It's the same. So that is something very nice you can do with this wonderful package. So thank you for watching this tutorial. I hope you have learned a lot. It was some way, but I hope you are going to benefit from this. So thank you for watching. See you in the next session, and check the links below for some more interesting materials, and then let me know your opinion on or something new that you want to learn. See you another time. Bye.